Hi, my name is Dylan, and today I'll be covering Elementary and Intermediate Algebra, Chapter 1.1. So, let's just cover what you need to know from this chapter. You should know what a variable and a constant are, what the different types of numbers are, how to use a number line, and how to find the average of a group of numbers. So let's start off with variables. What is a variable? And so a variable is just a way of expressing a number that can change, or a variable can be used to represent an unknown number. They don't really mean anything by themselves, but you can assign them a meaning. Let's just start with an example. Let's take the variable x. We just write down x on your paper or something, and that doesn't it doesn't mean anything. It's just a letter. But now let's give it meaning. Let's say x is the number of lollipops in a jar. So imagine a jar, and there's a ton of lollipops in it, and we don't know how much it is in it. Well, we just know that there is a number of lollipops. There's a fixed number right now, and let's just call this number x. However, x is not permanent because it can change. Because if you eat a lollipop or someone puts a lollipop in the jar, it'll change. And that's what makes x a variable, because it can change. And it's not the constant, it's not the same every time. So let's just count the number of lollipops in this jar. 1, 2, 3, 4. And we find out there's 100 lollipops. So now x is equal to 100 because there are 100 lollipops in the jar, and x is equal to the number of lollipops. However, x can change this, as I said before. If I add another lollipop into the jar, x is now 101. Notice how x is not constant. As I said multiple times, x will change depending upon what the situation if the situation changes. X is not equal to 100. X is rather equal to the number of lollipops in the jar, and it just happens that that number is equal to 100. If the number changes, x can equal 1,000, a million. It just all depends on the situation. So let's do some practice. Let's say x is equal to the number of cars in a driveway. What does it mean when x is equal to 2? So as I said, x is equal to the number of cars in a driveway. And if x is equal to 2, that means there's 2 cars in the driveway, because 2 is equal to the amount of cars. Now let's say 5 more cars drive into the driveway. What is x equal to now? So originally x was equal to 2. And that's how many. Just think about it. There's only 2 cars in the driveway. Now 5 more cars drive into the driveway. Now you have 7 cars in the driveway. And if x is equal to the amount of cars in the driveway, should now equal 7. So now a constant is different than a variable. A constant is also a symbol, but it's something that can't change. They're fixed to that number. As I said, variables can change, but constants stay the same. Let's just compare the two. Let's say you're at McDonald's and you want to buy some food, and let's just compare the differences. What's constant is how many hamburgers you can buy with $1. That price on that menu, you can't get them to change it. With exactly $1, you can only buy 1 hamburger. That's a constant. It's never going to change. However, the money you have can change. That's a variable. If we sign x equal to the amount of money you have, right now your wallet has 20, so that means x is equal to 20. But if your mom gives you $20 more, you have $40 now, and x is equal to 40. So x can vary wildly, can be 100, but what's constant is how many hamburgers you can buy with $1. And that's the difference between the two. So now we're going to cover the various different types of numbers. So let's start off first with natural numbers. Natural numbers are just what you'd probably know normally. 1, 2, 3, 4, and you keep counting. 6, 7, 8, 9, 10, and you keep going on to infinity. It just keeps on going forever. But natural numbers don't include 0. And they don't include negative numbers or anything like that. They're only this. See this pattern? 1, 2, 3. That's only like that. Now integers include natural numbers, but they also include 0 and the negative versions of the natural numbers. So this is like -6, -5, -4, -3, and you also go into 0, 1, 2, 3, and you keep counting both ways. So you can go from negative infinity to a positive infinity. It keeps on going forever. Now rational numbers are any numbers you can write as a fraction, or in the form n divided by d, where n is called the numerator, and d is called the denominator, and both of these numbers are integers. So this sounds kind of complicated, but just think about it as like 1/2, 2/2, 3/2, 4/2. Just if you see that all of these are written as a fraction, and both the top and bottom are both integers, and as long as you can write that, that's a That's what's called a rational number. So, for example, 2 over 2, that's just equal to 1. But since you can write it in the form 2 over 2, that's also a rational number. So, all integers are rational numbers. All natural numbers are rational numbers. Rational numbers include those, but they also include stuff like 1/2, 3/2. You can also have stuff like 1/3, 1/1,000,000th. That's a rational number. As long as you can write it in that form, that's a rational number. Now, what's complicated are irrational numbers. So basically, irrational numbers are numbers on a number line that aren't rational. So basically, stuff that you can't write in a fraction form. You can't write, for example, root 3 in a fraction form, square root of 5. You can't write that. You can't simplify that. You can't simplify pi. You can't do it. But however, you should also know that not all square roots are irrational. For example, the square root of 4 is rational because it equals 2, and 2 is rational. Now, decimals are a different way of writing rational and irrational numbers. 1/2 is equal to 0.5, but it's just a different way of writing it. And a bar above the number is used if parts of the number are infinitely repeating. So, for example, 1/9 is equal to 0.11, and there's a bar over the 1 because it keeps on going. So it's like 0.11111111. It keeps on going on forever. That's what the bar means. Now, real numbers are all rational, irrational numbers. They're all basically any number you can think of. That's a real number. They're all numbers on the number line. Any number you can think of, that's a real number. So now we can plot numbers on a tool called a number line. And so we're going to start it off right now. I'll draw a number line for you. So right now, it's very simple. You draw an arrow this way because the number line goes on forever, and you draw a horizontal line, and then you draw another arrow, and then you put little like vertical lines in the middle, and these mark various points, important points. So let's just say this one's 0. So what's 1 unit to the right of 0? It's 1. And then what is this? This is 2. This is -1, -2. And this keeps on going forever. This is -3. And right here, we can't see it because that's an arrow, but there's like -4, -5. And it keeps on going this way forever too. Now, this 1 unit, this doesn't have to be equal to 1. So I made it equal to 1, but you can also have it to equal like 100 or 5 or any. You can decide what the units mean, but it just means that when you go 1 unit, it keeps on jumping like that forever. So if the unit is 5, it go from 5 to 10, 5 here and 10 here, and that's what I mean. I'm sorry if I'm confusing you. And so however, there are other numbers besides these numbers on the points. That's what the point of a number line is to show. So, example, between 0 and 1, there's also like 1/2 could be like right here. This could be 1/2. This could be 1/3. There are other numbers here. So all of these numbers here, these are all the numbers on the number line are real numbers. 1 is a real number. 2 is a real number. 1/2. Even like the square root of 3, you can put this here because there is a finite value of it. However, a non-real number is something you can't put in a number line, but that's sort of advanced topics. I won't cover that. Yeah, so basically, sometimes when you draw a number line, you want to show a certain group of numbers. Let's say you want to say, I want all the numbers from 0 to 2. So the way you can do this is you draw a circle at the starting point, which is 0, and you draw a circle at the ending point too, and you sort of color in another line right here. Usually, like on a test or something, I would just draw in a different color, like a pen or something, and so it's like this. So the tricky part is if you want to include 0, you have to color it in. So I said all the numbers from 0 to 2, so it means, and I want to include 0, so let's put 0 here. So that we bubble that in. But if let's say all the numbers from 0 to 2 except 2, you don't leave bubble it in, and that's how you can show that you don't want to include this number as part of the solution. So that's basically your number line. It's pretty simple. It's something you definitely will have to know for algebra, for anything else really. You're going to be using it for multiple years. So it's just something you should nail like right now. So let's do a quick numbers practice. Let's take in the 7 numbers: 1, 3, -4, -5.5. 1/2, square root of 11, and 0. So let's go to the first question. Which one of these are natural numbers? Or which of these are natural numbers? Alright, so there's two of them are rational numbers, natural numbers, and then ones that are natural numbers are 1 and 3. Alright, so let's go to the next one. Which of these are integers? So for which ones are integers, we go 0, -4, 1, 3. Okay? So which of these are rational numbers? Okay, so we're going to natural numbers, rational numbers include all integers. So let's go 0, -4, 1, 3. So we also have to include fractions, because fractions can be written in that form. So 1/2. And a tricky one, it also includes -5.5, because you can write -5.5 in a fraction form, because it's also equal to -11 divided by 2. So that's also a rational number. However, not all decimals are rational numbers. That's something you should keep in mind. But if you can write the decimal in a fraction form, it makes it rational. So which of these are irrational? Alright, so there's only one of these are rational, and that's the square root of 11. Because you can't write the square root of 11, you can't simplify it into a fraction. Yeah. And so which of these are real numbers? Trick question. All of them are real numbers. So, now the next topic, calculating the average. To find the average of a set of numbers, it's actually pretty simple. You just add up all the numbers in the group and you divide by the amount of numbers. So, for example, let's take the statistic, number of cars a family has. So let's say one family has 2 cars, one family has 4, one has 3, one has 5, and one has 6. So to find the average, just add them all up. 2 plus 3 plus 4 plus 5 plus 6. And you'll find that equals 20. And if you divide by the amount of cars, the amount of numbers of families. So there's 5 families here. So 20 is how many total cars these families have. And you divide it by the amount of families to find out how much the average amount of cars per family. And then you'll find that it's equal to 4. So the average amount of cars a family has is 4. That's it for this video. Thank you for watching. I hope you learned something from this video.